billowing from smokestacks, diesel engines, and cooking stoves in villages and cities around the world. Black carbon, small soot-like particles that are produced whenever fossil fuels or other organic substances are incompletely burned.
One of the major sources of black carbon is indoor cooking with biomass fuels, firewood, cow dung, crop residues is a major source of fuel. And amazingly, roughly half the world's population, about 3 billion, depend on these fuels.
According to the World Health Organization, black carbon causes an estimated 1.5 million deaths per year due to respiratory ailments and other diseases. But beyond the public health implications, black carbon also has serious impacts on the environment. Dr. Veerabhadran Ramanathan at the Scripps Institution of Oceanography in San Diego calls it one of the leading contributors to global warming after carbon dioxide.
The reason we are thinking about black carbon and we are worried about it is that it's the most efficient absorber of sunlight. That's why it's blackish.
In the air, these tiny black carbon particles absorb energy from the sun. This energy gets converted to thermal energy, which warms the atmosphere. Inside his lab, Ramanathan compares black carbon samples gathered from different regions around the world.
If you think that's dark, and this is the filter collector next to the cooking stove of a woman cooking, that's exactly what she is breathing.
To track the concentration of black carbon in the air and the amount of sunlight it absorbs, he also flies unmanned aerial vehicles, or UAVs, directly into polluted air. With this information, Ramanathan can get a global picture of black carbon and how it spreads around the world, sometimes hundreds, even thousands of miles from its source.
To my mind, what this shows, each one of us is in somebody else's backyard. So we're not going to solve this problem by pointing fingers.
But the problem doesn't end there. As these particles get knocked out of the atmosphere by falling rain or snow, they accumulate on mountaintops and glaciers with additional negative impacts.
If you add just the tiniest amount of black carbon to that fresh snow, it'll change the amount of energy that it absorbs, cause it to warm more quickly, and eventually melt more quickly.
This process is called the albedo effect. As the soot darkens the bright white snow covering glaciers and ice caps, it absorbs solar energy, grows warmer, and contributes to melting the ice caps, causing them to shrink. Dr. Joe McConnell studies this effect in the seasonal snowpack in the Sierra Nevada mountains in the western United States. By measuring the temperature of the snow and the distribution of black carbon and other particles in it, McConnell and his team can find out how much black carbon contributes to snowmelt.
There's our sample.
In the lab, McConnell's research goes even deeper. He studies ice cores that span decades, like this one collected from Greenland.
This section of ice is about 130 years old, so this fell as snow in the 1870s or so.
Using a special instrument for melting ice cores, McConnell measures individual black carbon particles to find out how, and in some cases where, black carbon was produced decades ago.
Right now we're at around 1850, so this is, 160 years ago that this snow fell. So these bumps are coming primarily from forest fires that happened 160 years ago.
With this data, McConnell supplies global climate modelers with more accurate histories of black carbon and other emissions.
This is the most recent decade, 2000 to 2010, and you can see most of the emissions are now coming from this part of Asia.
But of all the causes of global warming, black carbon might be the easiest problem to fix, because unlike carbon dioxide, it stays in the atmosphere for only a short time.
The most appealing part of targeting black carbon to reduce global warming is its lifetime. It stays in the air less than a few weeks. So what that means is that when you initiate a policy to cut down black carbon today, they're gone 2 weeks from now.
Ramanathan has started a program called Project Surya, distributing solar-powered lanterns and cleaner, more efficient cooking stoves to families. One of his first test areas is a village in the Uttar Pradesh region of northern India. His goal is not only to reduce global warming, but also create a more healthy environment for people who rely on these cooking stoves.
So Surya is a scientific intervention project. It's also a demonstration to show that if these women could be given better stoves, which cuts down their emissions, it not only helps them, it helps the region and helps the planet.
Paving the way for a cleaner, brighter, and healthier future for the planet and its people.